All right. So, good morning, everyone. Thank you for joining us. We're going to talk about brain science this morning and what's happening in adolescent brains. This kind of covers kind of after 11, but you can take it younger and older. This is the same presentation that I gave at the summit and the same presentation that I gave regionally last year around this time. So I have no hard feelings if anyone checks out or checks in throughout the presentation. Just a couple of housekeeping notes, maybe if my presentation will work. There we go. I am recording this webinar and it will be available on our website, hopefully tomorrow, latest Monday. Sometimes it takes a little while to download, and I will put the slide deck up as well. If you're having trouble with audio, please call in, that's fine, no big deal. You're welcome to ask questions out loud. You can stop me at any time. I tend to speak fast. I'll probably speak slower today because I'm not feeling great, but if I'm going too fast, just slow me down or ask questions. You can also drop them in the chat box at the bottom if you'd like, or at the top, depending on where your chat box is on your computer. We will be using polls for this presentation, and to use the polls, you just click on the box and hit submit, and your answer will register with me. So I always start this presentation with this picture by Mark Parisi. He does a toddler one that is also pretty funny. And I like this picture not because of where the things are. They're not correct for where your brain is, but the size is kind of proportional. If you think about your peer pressure resistance as being real tiny, and memory for chores and homework and really about anything, also real tiny. Your judgment gland not functioning in a teenage brain, and we'll find out later that that's really true. However, memory for music seems to be big, right? And the rebellion center seems to be pretty big. And those are all somewhat correct when you're thinking about the teenage brain. So I just kind of like this cartoon. It's worth looking up the toddler one as well. It's kind of a what's yours is mine, what's mine is mine vision. So we start with the kind of 3 myths about the teenage brain. And the first being that raging hormones is the cause of all the problems in the world when you're a teenager. I know that I heard that when I was younger, and I'm sure most of you heard that as well, or still hear that. And although it is true, hormones cause a lot of things, growth spurts and stinkiness and hair and all kinds of fun stuff, it isn't really the only cause of adolescence problems and behaviors. And really what's causing a lot of it is just brain growth and development. Excuse me. And so it's that changing brain that, and the hardwiring and the pruning that's going on, that's causing kind of behaviors and problems, if you will. Hormones come and go, and we know that adolescence takes a long time. So if hormones are coming in waves, like you have a growth spurt, right, and then the hormones die off, then that can't be the cause of all of the things that go on in adolescence. Ooh, I love this one. If teenagers just need to grow up, right? That's just a really kind of restricted view of the situation. Adolescence takes a really long time, and that long time is really unique to humans. If you think of the animal world, you know, animals are born and they do have to kind of grow up right away. But our increased time in adolescence has a lot of flexibility in our brains, what allows us to make judgment calls later on that are different and more exciting. It allows us to meet new people and try new things
when they come in.
that animals just don't have a lot of time to do. Sorry, you guys, please be patient with me. Ooh, I'm sure all of you have heard this one too, right? that teenagers just want or need total independence. I know when I was young, and I'm sure a lot of you when you were young, or you've told your own kids, right? Just figure it out. You just need to do it. Just work on it. And I think today, especially in today's world, we don't do anything with total independence in a vacuum. I know that I still talk to my mom, and my parents. I talk to my friends, my spouse. I have several online groups that I'm a part of. I can Google things. In fact, I champion Googler. I like to look everything up. The problem with telling kids that they just need to figure it out or they just need to do it on their own and not giving them the instruction or just assuming that they can do that on their own can lead them down some hard paths, right? We've all probably looked something up and put in something that we thought was a really obvious search term only to pull up things that we were like, whoa, that's not what I thought I was looking up. And so we kind of forget sometimes that we have to teach kids to do things. There was an example given recently in one of these classes of a child, a teen who liked to make bath bombs, and they forgot to clean the tub every single time, and mom was pretty frustrated. And then you kind of remind yourself what, like, not only the forgetfulness of teenagers, but do they know how to clean the tub? Like, have we taught them how to clean? Like, it seems really intuitive, like, go clean that, but they may have never used chemicals before because when they were younger, we didn't allow them, or did we teach them how to properly do things? And so you just have to kind of keep that in mind, that they forget, and they're very forgetful, and that's normal in the teenage brain, but also that we have to teach them how to do the things that we want them to do. So I'm always like, this is your brain. And so on the inside of your brain, the part we can't see, is kind of your ancient brain, your lizard brain, the brain that you're kind of born with. And that's your fight, flight, or freeze response, right? Pretty easy to scare babies. Like, you come born with that capability to be afraid and to fight or flight. And then, but we hear a lot about the first 5 years of life in your brain. And that is super duper important. That's incredibly important. That first 5 years, you're making a lot of connections, thousands and thousands and thousands of connections. And your brain reaches 90% of its adult size by age 6, right? But does anyone want to guess, and you can unmute or you can type, how long we kind of go through adolescent brain development until we reach a almost fully formed adult brain? What age would you say you have? I'm seeing 25. Anyone else want to guess? 25? Yep. Takes about till you're 25. Right? That's we make a lot of decisions before the age of 25, right? Where we go to college, sometimes who we're going to marry, whether we join the military. And we make those decisions without a fully formed brain. And not that those are bad. And certainly by age 18, you're headed down the path of having a fully formed brain. But yeah, when we kind of think about the pressure we put on kids to make good decisions and choices, and they're doing that without having all the information in there. So after your internal lizard brain comes the occipital lobe. It's in the back of your head right there, but that's the part that's responsible for processing visual information. That grows pretty early, and it's the first lobe to fully develop. But then what happens is kind of an interesting piece of information. The parietal lobe and the temporal lobe come on board around the age of 16, will be fully mature. And those are the parts of your brain that control sensory information, right? And emotions, right? Emotion. Can you imagine? So hopefully a bunch of you just went, oh, because think of those two things together, right? Sensory information coming in, and then you're controlling everything with emotions. And so what are you not seeing? What's not on board yet? What's the thing that takes until 25? Anyone want to hazard a guess? Or no? Because you probably heard me say it. Oh, someone wants to type it in. What's missing? All right, I'll give you a clue. Your frontal lobe, right? This is your CEO, your thinking center of your brain. This is where you make judgment calls, problem solve, self-control, right? And that's the last part to mature. So we have sensory information and emotion information on board by age 16. And then we have another 10 years to fully form judgment and control. This is one of those areas that just kind of learning this portion, you can kind of go, okay, I see where some mistakes may have happened as a young person. We're going to see if this video works. It always seems to take a minute for me. I don't know why. There we go. Hopefully everyone can hear it.
Chapter 4. The Mysterious World of Neurons. Mojo arrived at school one day to find a happy surprise. His new device had finally arrived. But just as he was about to turn it on, Katie showed up. Mojo, what are you doing? Becoming a genius, said Mojo. How is that thing going to make you a genius? Said Katie. It's going to make my brain grow by zapping it with electricity. I thought that was obvious. Mojo, I think it's time for you to find out how your brain really works, said Katie. It's time to visit Miss Clara. Now, Miss Clara was a most curious character. Not long ago, she was a world-renowned neuroscientist, but her discoveries had inspired her to try a new challenge. And that's how she became an art and drama teacher. Miss Clara's classroom was in an expansion trailer, far away from the main campus. Katie and Mojo made the long climb up the hill and found Miss Clara meditating in her garden. Katie, Mojo, I've been expecting you, said.
Oh, sorry guys. I was playing around and it I was trying to turn it up for you guys.
I've been expecting you, said Miss Clara. Katie says you know how our brains work, said Mojo. Well, even scientists like me don't understand exactly how our brains work, said Miss Clara. But we do know a little. We know that your brain is made of tiny bits called neurons. Now, when these neurons connect, they send electrical signals back and forth to talk to each other. Everything you can do, from reading to riding a bike, only happens because your neurons connect. Now, here's the really fascinating thing. You have the power to change how your neurons are wired together and learn how to do things you never thought you could do. How? Asked Mojo. There is only one way, said Miss Clara, leaning closer. Learn challenging things. Mojo was fascinated. He turned to Katie. Katie, we're going after the biggest challenge you can imagine.
All right. I like that video because it kind of is a really basic way to say what's happening in our brain, right? Like we have thousands of connections. That's what we build up through age 6. And then we start to prune them. And then we start to hardwire in everything that we want to keep. And now it doesn't want me to let out. There we go. So a teenage brain is not just an adult brain with less life experience. And that was kind of the original thought for a long, long time until imaging kind of got better. We knew that by 6, you had 90% of the size of an adult brain. And so the assumption was made that you were just a small adult and you just needed to work harder and learn more things. But then imaging got better, right? And we kind of started to discover, and this is where I'm like, this is new science. And by new science, I mean like in the last 15, 20 years, because science doesn't move super fast. So what we've learned through studying brain imaging is that the gray matter volume will decrease over time, but the density will increase in a wave. And this is what we're seeing, what I showed you earlier, from the back to the front as those unwanted neural connections are pruned and the ones we want to keep are strengthened. And so in this first picture, you can see, here's age 5, and here's your occipital lobe and your lizard brain kind of in the middle. They're turning blue, and in this image, that blue is the maturing. Then as we creep up to 16 area, here's those maturing of the your sensory and your parietal and temporal lobes. So your sensory and emotions coming on board. And then as we head up to 18, you're kind of starting to see that maturity here. And then by age 25, you have a fully mature brain. Ish. And I say ish. Obviously, there's people on front end and back end of that age. This is just the average. And think of it a network wiring upgrade, or for those of you who are a certain age like me, down here is like VHS, right? And then we got DVDs, and that was amazing. And now we can stream videos, right? And it's super fast. And so that's basically what's happening. Like, right, you had dial up down here, and then, we had cable modems and whatnot, and now everything's just super fast and in the air, right? We have Wi-Fi. That's what's happening in your brain. So how is a teenage brain different than an adult brain? So dopamine. So we've all heard about dopamine, right? What does dopamine do? It's kind of the reward drug in your brain, if you will. And not to bum anyone out, but we have more dopamine than we're ever going to have in our adolescent years. And that means that rewards become really, really important in the teenage years. They'll seek out rewarding experiences over just about anything else. And they will outweigh consequences to raise up reward in their minds, because they're seeking that kind of dopamine high. So that leads to hyper-rational thinking. There's kind of this misconception that teenagers just don't think things through. And we ask that question a lot, like, what were you thinking? Because as an adult, we kind of feel like they weren't thinking about it. And really the opposite is often true. They did think about it. But what happens is that the thrill or the reward outweighs those consequences. And so we're speeding down the road and we're like, what are you thinking? And they're like, I'm thinking that there wasn't anyone else on the road. And you're like, that doesn't mean you can't crash. But they're thinking, oh, I took precautions, it was fine. The consequence to them was low. The thrill of speeding or looking cool to their friends was high. And so they're seeking that thrill and that high. And I usually ask at this point if there's anyone who wants to share an experience, like if you had an aha moment of, I've done that. And if not, I will share one. Anyone? Okay, you're all willing to let me give you the example. That's fine. I'm going to show you in pictures what this was. So on a band trip, we were in Hawaii, which is lovely. We went to Hawaii on a band trip, and we went to this lookout, which is the top picture here, and it's called Poly Lookout. And this is Waikiki. It's gorgeous, right? It didn't really look like this when we were there, but it's kind of foggy. Neither here nor there. This is the lookout. It's gorgeous. You can see half of Hawaii, it feels like, from up there. This is the actual lookout. So as you can tell, it's kind of a cement surrounded lookout. And what we had was a band member who said, you know what I'm going to do? There is a second walkway down below. And he said, I'm going to jump off of this ledge onto that walkway below. And I'm going to jump in the air and you guys take a picture. And it's going to be amazing. It's going to look like I'm floating over this beautiful valley. And there's like 30 of us. And we were like, yes, do that. And, you know, at the time we were like, it's fine. The picture's going to be great. He can make it down to that ledge, no problem. So literally like 30 people in Adolescence said, cool, we'll take the picture for you. You do that. And you know, looking back, I'm like, where was our band director and assistant? Like, why was this not stopped? But literally everyone was like, yes, please do it. Multiple people took pictures. So yeah, he's gonna jump here, gonna have this beautiful background. For those of you who can see this last picture, that's the walkway that he jumped down to. So he jumped off here, jumped up in the air, and then came all the way down. This is a very tall person, but you can tell that it's probably a good 20 feet or more down. And what you can't see is below this railing, it drops sheer rock face to like highway. He jumped, took pictures. Picture was incredible. I will let you know that. He jumped down, broke both ankles, and immediately all of us were like, oh, dumb idea. Stupid. Should not have done that. He's okay. I tell that story because he's okay. And I also tell the story because it's one of those times where it was an immediate reaction of like, that was dumb. Should not have done that. But at no time in 30 people under the age of 25 did we ever think that would happen. We kind of minimized that consequence because the picture was going to be cool. He would look cool doing it. We framed that picture with his hospital tags and gave it to him later. It was a really incredible picture. And then my brain, I hope that he has that hanging for his kids as a reminder to not do that. But that's an example of hyper rational thinking, right? We thought it through. It wasn't impulsive. He talked with a whole group of kids and did it anyway, right? So quickly, I just want to talk about myelation. So myelation is the brain's white matter. You've heard about gray matter and white matter. The myelin is the part that covers your neural connections and makes the connections between two things. And that makes the connections go quicker. So if you think of like your phone charger, has kind of that white or black or colored coating over the top of the actual electrical cable. That's allowing the signal to go quickly. And if you again think of your phone charger, and I'm sure most of you have had a phone charger that starts to fray because we've bent it too many times or whatever, and then you have to hold your phone in a certain position to get the connection to work and to have it charged. That's what happens when the myelation strips off, right? It's not called myelation on a phone cord, but we're talking about the brain. So if that starts to strip off, or it's thin, or it's not working properly, those brain connections don't work as well. And that happens, we hear about myelation a lot again in those younger years. That's why it's really, really important to have proper nutrition. And that's why we say breastfeeding, proper formula, moving into like whole milks or things with lots of healthy fats, because you want that myelation to be good and thick. And so if kids have had improper nutrition or are food insecure, this myelation can be affected. And it's not something you would necessarily know, but it's just good to keep in mind. So pruning, this is the heart of what we're talking about. So in adolescence, we prune back those thousands and thousands and thousands of connections, and we take it down. The things we don't need, we get rid of, and the things we use all the time are hardwired in. And we can hardwire in good stuff, and we can hardwire in bad stuff. So you want to make sure that as much as possible, we're hardwiring in good stuff. But if languages is a good example. If kids are in really great immersive preschool programs and they learn a second language and then they never use it again in elementary school or going on, they will lose it. It gets pruned out. That'll happen as an adult. I learned a language, of course, in high school. Never really used it again, and now I do not speak that language because I did not hardwire it in enough and use it enough to keep it. Right? So I just like this little hold still, okay, but not too much off the top, right? So that's your pruning. They're pruning those synapses off the top. So by age 11 and 12, right, we've made those connections. We start pruning them. That's what we saw in the picture, right? Connections are reinforced or strengthened, not used, kicked out. Teens have extra unconnected synapses right up here in that frontal lobe. This is what causes a lot of that forgetfulness, is those synapses don't have anywhere to go. They're not connected real well yet. And so we kind of just forget what we're doing. And that's because that judgment, rational thinking part of our brain isn't working up to its full potential yet. So this is where you're going to need your computer, and we're going to do some polls because we're going to talk about the study that kind of led to the start of the science that said, whoa, 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 kid brains are not small adult brains. So Dr. Deborah at McLean Hospital in Belmont, she kind of set out thinking that was what she was going to prove. So she ended up proving that brains don't work the same. Teen brains are not the small adult brains. But she looked at the brains of 18 kids between the age of 10 and 18, and she compared them to adults using an MRI. And what she did was she showed them adult faces, and she asked them, while she was scanning them, to identify the emotion on the faces. And so we're gonna play this game so that we can see what was happening at that time. It's kind of a fun game. So hold on while I put up your poll. Where is my clicker? Doop, doop, there we go. Uh-oh. Anna, you need to log out. You killed my poll.
I will right now.
Thank you. Sorry.
That's okay.
We'll see if that worked. No. Well, you guys, while we wait for that, what we'll do is, if you can put in the chat, I like usually doing this anonymously so that we get a good idea of what everyone's thinking straight off, and you're not kind of swayed by what others are putting in. But why don't you put in the chat what emotion, and it's only fun if you guys participate, what emotion you think this is that they're showing on the screen. Are they showing anger, joy, surprise, or fear? All right, we're going surprise. Surprise. All right, I think I have 3 people saying surprise so far. And I think that's, you guys are pretty much it right now. Yeah, I think our polls are just not going to work today. Nope, no, I'm not working. Oh, so the thought was that this was fear. That's what these actors were asked to portray. Surprise! It's fear. It's hard, huh? So we're gonna look at this face. What is this emotion? happiness, sadness, anger, or surprise. Okay. All right, so you all are in agreement currently that this is anger. And you would be right. That one is showing anger. All right, so what is this emotion? Surprise, happiness, fear, or sadness? Okay. Like for my own personal, I can't look at the guy in the middle. He throws off everything for me. I don't know. Any more guesses as to, Jen, did you have a guess that you wanted to make? You're like, no, I'm not making any more guesses. Okay, you guys are all in agreement that it's surprise. Yes, surprise. Right, it's a little bit easier because you've seen fear now, right? That wasn't a surprise, so I'm gonna have you look at this one. Joy, sadness, fear, or anger. Okay, okay. All right. So you guys are all in agreement that it's joy. This one I'm not going to show you the answer to, and I want you to look at this face instead. No, I will not go back. Let's answer that now. So is this joy, sadness, fear, or anger? Okay. Okay. So you guys all said joy. Again, I want you to look at these two side by side. And if you can, quickly either type or unmute yourself and tell me why you think both are joy or why one's different than the other, what you're noticing. Bigger smiles. Anything else? That's all you noticed, guys? Bigger smiles? Some people have noticed that, like, oh, more engagement facially on the right. Yeah, people have noticed, you know, like their eyes crinkle up, kind of squinty, the bigger smiles, right? So the one on the left looks fake, the one on the right looks right, or more genuine. And Emily, that's the answer. So on the left is fake joy, right? And on the right is real joy. But adults are really good at this, right? We hide emotions quite a bit. I mean, we've all been in a situation where we're upset or angry and someone's like, are you okay? And we say, we're fine. And this is really hard if you think about a kid who's processing through emotion to understand. You know, it's still difficult, even for adults, right? We all on the very first one guess the wrong answer, and right? Oops. So yeah, teens misinterpret facial emotion 40% or more of the time, literally 50% guessing whether they will be right or wrong. I think we've all, if you work with kids at all, or if you have kids, we probably have all had or seen the kid where you could be crying, huge tears, and they're gonna be like, when's snack? Like they've misread the situation entirely. On the flip side, we've all probably had a kid or seen a kid who's like, why are you mad at me? Why are you yelling? And you're like, I have no idea what you're talking about. I'm fine. I'm not mad at you at all. And that's because they are, right? We process things differently in our brain. So these are her images. And so we can see this is the teen image first. They're heavily processing through that emotional center, right? They're trying to interpret your emotion through their own emotions and sensory needs. And so if they're not upset, right, and they're not using really good context clues, they won't necessarily know that you're upset. And she did test up to age 18, so there's a little bit of trying to use that frontal lobe and use those context clues on what might be happening, like squinty eyes, bigger smiles. But for the most part, they're using that emotional center of their brain. It's gut reaction, which is a 50-50%, 50-50 action. Adults, there they are, using that frontal lobe. They're going to put things in context and they're going to think things through, kind of like what you guys were just doing on that last picture. Also, adults tend to go, they had a really bad day and I know that, their child is sick and maybe they didn't sleep very well. So they might not be in a great mood. And so that's all rational thinking in the front of our brain. We do use a little bit of our emotions. That mean we're human. We're going to process emotion with some emotion. But we tend to try to figure things out as adults more than just guess and using emotions like we do when we're younger. Did that help anyone right there? Just go, oh, I have that kid. I've seen that kid. All of my kids are that kid. I was doing this training the other night, and one of the teachers was like, I had a child just break down because they could not decide between tater tots and French fries. And they were sobbing. Like they just could not get past that emotion. Right? Because if your frontal cortex is not working and you're processing through emotion, decisions get really hard. And even if basic decisions get really hard, right? So why and how does this cause a problem? Early exposure to drugs and alcohol can lead to learned substance abuse. Remember when I was talking about hardwiring things in? You can hardwire in bad things just as easily as good things, right? So you can learn substance abuse, right? 6.9% of 12 to 17-year-olds today already meet the criteria for substance abuse. Does anyone want to write in chat what they think the percentage is in Idaho? If you had to hazard a guess, if 6.9% is the national average of 12 to 17, Jen saying higher. I'll give you a clue, it is higher. Does anyone want to? It's almost doubled. It's 13% in the state of Idaho of kids 12 to 17 who meet the criteria of substance abuse. We kind of have an epidemic, and this is 12 to 17, right? So think middle school going into high school. We tend to skew high and think high school students, but really we need to skew a lot lower and start talking about substance abuse by elementary school and certainly by the start of middle school. Teenagers who begin using any addictive substance, drugs, alcohol, whichever, before the age of 18 are 6.5 times more likely to develop substance abuse disorder, and that's due to the hardwiring into your brain, right? It's way higher. In fact, it's 1 in 4 if they start using before the age of 18, compared to 1 in 25 if we start over the age of 21. We put a lot of resources and time into high school and college age abuse, when really, again, it needs to start lower, and those warnings need to be given earlier, right? And not just warnings. Again, teaching kids life skills, right? We have to teach them how to manage anxiety and depression. We have to teach them how to communicate what they want, communicate with friends. Those are all important skills that we have to actually teach kids so that they hardwire that in and then don't seek out the rewards from drugs and alcohol. They're seeking out rewards from clubs and activities and learning new things, and that those rewards are just as valuable. Right? Can lead to irrational thoughts and doing things. But we can unlearn, right? We can unlearn destructive tendencies as well. And so this is where helping really takes a part. Adolescents are less likely than adults to seek treatment on their own. And that kind of goes back to the very, very beginning of this talk where I said, we tell kids a lot to figure it out. This isn't the time. This is not the time for telling them to figure it out because they can't. They won't. They don't always know that they're suffering from addiction, right? This is new to them. They've never done this before. The highs will seem high, right? The rewards will seem great. They might seem like they're cooler with their friends. They're getting the physical reward from the drug itself. So it's really hard to see that they have or, have a problem. And a lot of times we brush teenage problems off as, they're just teenagers. And so they have to be able to seek help. So they have to have trusted adults in their lives to do that. Here's the really great truth and kind of nugget to take away about this part of the talk. This is the sad part of the talk. If they're identified and treated in adolescence, especially if they're on the mild or moderate end, right? Not only can we reverse the addiction, we reverse that addiction for life, right? They're less likely to ever abuse a substance, any substance again, because we've hardwired back in, right? They've kind of gone through the process of learning the substance abuse, putting that in, and then we took the process of taking it back out and hopefully substituting in really good practices. And I will also say, you have to work on and solve some of the problems that probably led to substance abuse. And not solve, but help with either trauma, the neurodiversity, either other chemical dependencies, homelessness, food insecurities. If those continue, then you can slide back into substance abuse. But if those problems are addressed, the substance abuse is addressed, we can unlearn and not go back to substance abuse. That's the good news. So we just have we have like 10 more minutes. Sorry guys. We have to remember that this is the best time, right, to try new things. This is where out of school time programming really takes an important role in those teen and tween years. This is when, the studies have shown that kids decide to go on to college like by middle school. Again, we put a lot of effort into high school, and we have to kind of slide back and say, what are you interested in? What do you want to learn? Let's look at lots of different things. Get that, get those brain juices flowing. What do you guys want to try? What do you want to do? And with that is meeting new people. And it may seem like they don't want to meet new people, but really this is like the best time to try new clubs, new organizations, new classes, and meeting new people and trying new things, because they naturally want to expand their social circle, right? They're looking for that cool factor, the high. And if they do that and they can seek out healthy ways to meet new people and try new things, they're going to be safer and healthier in general. They seek out novelty. They don't want to hang out with their family. Right? It would be sad for us, but great for kids, and that's okay. That's healthy. That's normal. Seeking friends and human contact is supremely human trait, and it's something, again, that long adolescent time is a good thing. That heightened flexibility in our brain, so that as we get older, those things stay with us. Tip trick, right? If you are annoyed or mad or sad or whatever you're feeling, just as importantly happy, you have to say so. You have to tell kids what you are feeling. Naming your emotions helps them learn about their own emotions. And it also kind of just helps them navigate the world better. If you can't get too specific with kids in the adolescent years, you just can't. If you have rules that you want to explain, super specific. If you're upset, super specific. It is extraordinarily valuable to that kid who asked you for snack while you're crying, for you to say, now is not the time. I'm really upset. I need a minute. I'm gonna walk away. I'm gonna come back and then we can talk about snack. Or I'm upset. I need you to go see Julie over there. And I will catch up with you later. If you're mad and you did yell or something happened in programming, no one's a saint. That's not, I mean, we know that. It's also valuable to come back the next day and say, I'm sorry, I was really upset with you. Or I wasn't upset at you. There was something else that was happening and I took it out on you. But naming those emotions, walking them through what happened, that's how kids learn, right? Oh, we kind of discussed that. Kids enter a world made by their parents, but they do not live or survive or go on in the world that was made by us, right? They will make and run their own world with their own peers. I certainly don't live in the world that my parents lived in. Social media, my kids already do not live in the world that I have lived in my life. I didn't grow up with social media or the internet until almost college, right? They will have it immediately. My kids already can work Alexa and phones and whatnot, and we have to change what we do and how we think for them, and then they will take care of us when we're old. So we have to make sure that they learn how to do things, right? And then I always end, you got to have a sense of humor, right? Every day is a new day. Take everything with a grain of salt. They're not mini adults. They will not act like mini adults. And we just have to kind of end up in their world, right? It's funny. It's going to be funny. Take it as funny. Laugh at yourself, laugh at them, get through it, right? Everyone goes through adolescence. And we'll all get there. This is the end of this particular talk. We have about 10 minutes and I can certainly stay on the line. I should add that this talk was for 80% of the kids, 80% of the time, and I did not fully address trauma or neurodiversity. We certainly can, or if you have questions that you want to ask, I can stay on the line and answer those specific questions. Or you can always get a hold of me on the website or through my email, idahooutofschool.org. And does anyone have questions or concerns or thoughts that this brought up for them? Because if not, I will just end here. We'll do behavior. We don't have enough time to get into behavior, but we will hit behavior. That this will be like the first part, and the second part will be on behavior in the upcoming months. And we'll go into what you can do with this information. But otherwise, you guys are free to go, and I will stay on the line for a few minutes if anyone wants to chat.